For decades, the fundamental paradigm of a homicide investigation relied on a simple equation: identify the victim, retrace their final days, and find the killer. When a victim cannot be named, the investigation is instantly paralyzed. Without a name, there is no timeline and no motive. This was the rigid boundary of criminal investigations. Breaking through this wall required a complete phase shift in understanding human identity. The established system of identification was strictly comparative and highly limited. Forensic examiners relied on fingerprints or dental records, manually matched against missing persons reports. Even early DNA profiling was fundamentally a closed loop. A genetic profile was only useful if it directly matched someone already in a government database. Without prior criminal records, the system was completely blind to both the killer and the victim. Operating within this restricted framework, handling unidentified remains in the late 20th century was a grueling, analog process. Medical examiners charted dental restorations, noting every filling, and sent these records via teletype to surrounding jurisdictions. Clay reconstructions and composite sketches were published in local newspapers, relying entirely on the fragile hope that a member of the public might recognize the face of the dead. Detectives spent thousands of hours physically cross-referencing these approximations against towering stacks of missing persons reports. It was a game of statistical probability played with incomplete data. If a victim was found several states away from where they vanished, the procedural safety nets failed. Physical evidence was boxed up and relegated to deep storage, waiting for a technological miracle. That miracle arrived from the commercial sector, triggering a monumental shift in the investigative landscape. The rise of direct-to-consumer DNA testing created massive, publicly accessible databases of genetic information. Investigators realized that DNA was no longer just a rigid, one-to-one identifier. It was a sprawling, interconnected map of biological inheritance. By extracting a detailed genetic blueprint, forensic scientists could finally bypass the closed loop of government databases. The consequence of this scientific pivot was immediate. Law enforcement could now upload a genetic profile to open-source platforms, searching for partial matches indicating shared ancestry. This was the birth of forensic genetic genealogy. A killer who meticulously avoided leaving fingerprints could now be tracked down through the DNA of a distant cousin. The protective anonymity of the unidentified was replaced by a web of familial connections. For the families of the missing, this technological evolution brought a sudden, agonizing end to decades of ambiguous loss. Generations of relatives lived under the crushing weight of unanswered questions, wondering if a runaway daughter might one day return. The application of genetic genealogy shattered those fragile hopes in an instant. A sudden phone call replaced years of quiet desperation with the stark, brutal reality of murder. This emotional shockwave extended to the detectives who carried these unsolved cases through their entire careers. Many investigators kept photos of unidentified victims pinned to their bulletin boards, haunted by the knowledge that they had failed to return a stolen name. The breakthrough meant they could finally write a name on a headstone, but it also forced them to confront the sheer scale of unchecked violence. Nowhere was the transformative power of this new forensic reality more severely tested than in the dense, quiet woods of New England. Long before the modern science existed, a hunter walking through a patch of timber stumbled upon a rusted 55-gallon industrial drum. This discovery initiated an investigation that defied every traditional technique, pushing law enforcement to the absolute limits of their capabilities while waiting for science to catch up. The site of this grim discovery was Bear Brook State Park in New Hampshire. Inside that first barrel, and another found years later, lay the dismembered remains of a woman and 3 young girls. For decades, their identities were erased by a phantom serial killer. To unmask this predator, a man eventually identified as Peder Rasmussen, investigators had to pioneer a new frontier of science. In 1985, the physical reality of the Allenstown crime scene presented a forensic nightmare. The first barrel lay discarded near a burned-out store in Bear Brook State Park, obscured by years of unchecked undergrowth. The 55-gallon drum had endured the brutal extremes of New Hampshire weather, suffering through freezing winters and humid summers that accelerated the degradation of the evidence inside. Inside the rusted metal casing, investigators found the heavily decomposed remains of an adult female and a young girl, both wrapped in plastic. The surrounding soil, the rust flaking off the drum, and invasive root systems had compromised the biological material. The environment slowly erased the physical markers needed for traditional identification, leaving detectives with little more than skeletal fragments and dead ends. To understand the magnitude of the eventual breakthrough, one must examine the mechanics of forensic DNA analysis. For decades, law enforcement relied on short tandem repeat, or STR, profiling. This system isolates highly variable regions of a person's DNA to create a unique genetic fingerprint. It is designed for direct comparison, effective when matching a suspect sample to crime scene evidence. However, the STR system has a critical limitation. It requires a known target. If a suspect's profile is not already in a criminal database, or if an unidentified victim has no immediate relative searching for them, the fingerprint is useless. It cannot predict physical traits or trace distant ancestry. The science of the era could confirm an identity, but it could not generate a new lead. As the Bear Brook investigation dragged into the 21st century, the forensic strategy had to evolve. In 2000, a second barrel was discovered just 100 yards from the first, containing 2 more young girls. Investigators exhumed the original victims and subjected all 4 bodies to updated testing protocols, carefully extracting samples from dense bone tissue to bypass environmental degradation. These biological samples were sent to specialized laboratories where forensic anthropologists applied stable isotope analysis. By measuring the chemical signatures of oxygen and strontium absorbed from drinking water, technicians mapped the geographical regions where the victims had lived. Simultaneously, geneticists worked to extract viable autosomal DNA, fighting against decades of bacterial contamination to build a workable profile. The immediate consequence of this genetic extraction was a chilling realization. The data proved the adult woman was maternally related to the oldest and youngest girls, confirming they were her biological daughters. However, the middle child found in the second barrel shared no genetic connection to the others. This biological discrepancy forced investigators to expand their profile of the killer. Furthermore, the genetic profiles failed to trigger a single match in the national database. The traditional forensic avenue was entirely exhausted. This failure became the catalyst for a radical pivot. Law enforcement realized they could no longer rely solely on criminal records. They had to turn to the consumer market, uploading the extracted genetic markers to public ancestry websites to cast a wider net. The revelation that the middle child was biologically unrelated to the family she was buried with struck a deep, unsettling chord. It meant there was another mother out there, completely disconnected from the primary family, who had likely spent decades wondering what happened to her daughter. The genetic data transformed the middle child into an isolated victim, amplifying the urgency to restore her identity. For the geneticists staring at the sequenced data, the strings of code represented an overwhelming responsibility. Every failed search prolonged the erasure of 4 human beings. The detectives who had guarded these files for decades felt the agonizing proximity of the truth. The answers were locked inside the victim's own cells, waiting for the right distant relative to finally break the silence. The silence was broken by a radical new approach: forensic genetic genealogy. Investigators uploaded the DNA profiles extracted from the remains to open-source databases designed for hobbyists tracking ancestry. This bypassed the limitations of the criminal justice system, which only flagged individuals with prior convictions. Instead, the search tapped into a massive, civilian-populated web of genetic data, looking for anyone sharing a fraction of the victim's DNA. This pivot required a completely different investigative mindset. Detectives were no longer hunting for a direct match. They were searching for third and fourth cousins. Once a distant relative was identified, the investigation moved from the laboratory into the realm of historical research. The goal was to build a sprawling family tree backward in time, find a common ancestor, and trace the branches forward to locate the missing victims. The crime scene shifted from the physical woods of New Hampshire to a vast, digital landscape of historical records. The environment of the investigation became a labyrinth of digitized census data, faded birth certificates, marriage licenses, and obscure obituary columns. It was a world of microfiche and digitized archives, where evidence was buried not in dirt, but in centuries of bureaucratic paperwork. In this data-driven environment, genealogists connected thousands of disparate nodes. They mapped out generations of families across different states, navigating misspellings, unrecorded adoptions, and forgotten name changes. The workspace was defined by sprawling charts and complex spreadsheets, slowly narrowing a pool of distant relatives down to a single family line that had gone quiet in the late 1970s. As the genealogical net tightened, it ensnared the architect of the murders, revealing a highly sophisticated system of evasion. The perpetrator was identified as Peder Rasmussen, a man who weaponized aliases to construct an impenetrable shield around his crimes. He fabricated entire histories, living as Bob Evans in New Hampshire, Curtis Kimball in California, and Gordon Jensen in between. Rasmussen's operational system exploited the blind spots of the pre-digital era. He moved fluidly across state lines, shedding identities whenever law enforcement closed in. By compartmentalizing his life and targeting vulnerable women with children, he ensured his victims were isolated from anyone who might report them missing. His methodology relied on the lack of communication between regional police departments, allowing him to operate as a geographic phantom. The procedural breakthrough came when investigators cross-referenced Rasmussen's timeline with the genealogical data. Analyzing employment records from the late 1970s, detectives placed Rasmussen, then living as Bob Evans, working as an electrician in Allenstown. They documented his direct access to the property where the barrels were ultimately dumped, linking his physical movements precisely to the site of the murders. DNA testing then provided the undeniable link. A sample taken from Rasmussen's exhumed body in California was compared against the genetic profile of the middle child found in the second barrel. The results confirmed a biological match. The procedural chain of evidence was complete, proving that the man known as the chameleon killer was physically and biologically tied to the crime scene. The consequence of this genetic match was devastating. It established that Rasmussen had murdered his own biological daughter alongside 3 other victims. This revelation exposed a level of calculated brutality that defied standard criminal profiling. It meant the killer had lived with, traveled with, and ultimately slaughtered his own flesh and blood before sealing her in a steel drum. The ultimate consequence of the genealogical investigation materialized in 2019, when the primary victims were finally given back their names. The woman and 2 of the children were identified as Marlise Elizabeth Honeychurch, Marie Elizabeth Vaughn, and Sarah Lynn McWaters. After nearly 40 years of anonymity, the forensic breakthrough permanently erased their status as unidentified bodies, closing the darkest chapter of the Bear Brook murders. The woods of Bear Brook State Park no longer hold the secret of the 3 named victims, but a profound void remains. The middle child, Peder Rasmussen's own biological daughter, was never reported missing by anyone in his transient life. Because her maternal lineage remains unknown, this little girl lacks a true identity, existing in state records only as the middle child found in the second barrel. The tragedy of the Bear Brook site persists as long as she remains a nameless casualty.
resting beneath an incomplete headstone. The resolution of the other identities triggered a permanent paradigm shift in law enforcement protocols. Genetic genealogy moved from an experimental last resort into a foundational investigative mechanism. Cold case units across the country began re-evaluating their unsolved files, realizing that degraded DNA samples could now map direct family trees. This methodology fundamentally restructured the forensic landscape. Agencies established dedicated task forces, allocating specific funding to extract DNA from historic crime scenes. The barrier of anonymity was dismantled, proving that time and decomposition could no longer protect perpetrators who relied on the limitations of 20th century science. For the families left in the wake of the violence, the human aftermath of this breakthrough brought a devastating finality. Relatives of Marlise Honeychurch absorbed the shock of a reality they had feared since 1978. The decades of agonizing speculation were replaced by concrete, documented truth. The physical return of the victims allowed their surviving families to reclaim them from the clinical environment of an evidence locker. Memorial services replaced forensic storage, granting the community a quiet space to mourn the actual people who had been reduced to a grim local legend. In the larger context, the 2019 identifications permanently changed the operational baseline for unsolved homicides by combining traditional legwork with open-source DNA databases. Investigators proved that fragmented genetic material could track a killer's movements across decades, setting a precedent that cracked dormant cases nationwide. Yet, beneath the triumph of forensic innovation, a quiet stillness returns to the dense New Hampshire timberland. The rusty outlines of two steel drums are gone, but the soil of Bear Brook State Park will forever hold the scar of a killer who waited in the shadows for science to finally catch up.